All right. Well, welcome everybody. Welcome back to the Inicus project. I'm excited to continue working on this thing. You can see that I've put the lights up around the mic stand here because this seemed to work out well last time, so I've just decided to do that from now on so y'all can see what's going on. And we'll just work from that. And then let's get a few housekeeping things out of the way. So, last time we made this thing and it was running really fast. At least it appeared to be running really fast. But now while running it, I've done something with the code and it's running way slow. As you can see, the light's ticking right now. This is the fastest refresh rate they have if I'm changing the colors of every single LED. And it's way too slow. So we're going to try and fix that to start with. And then after that, we're going to be writing a Python library to control this thing from the computer so that I don't have to do as much code there, and I can basically hide some of that stuff underneath a few communication layers to make this easier. I apologize for starting late today. I had something come up that I had to take care of, but we're good to go now. A couple of other things. I decided to introduce this new screen style, which looks like this. And I've been toying around with different layouts for the stream. I'm not totally sure if this is, I don't think this is the best I could have come up with just yet, but it is something. And I will make the font bigger on the screen that you're looking at here. I'll switch over to Arduino because that's a little bit bigger font. There we go. But hopefully this layout is a little better. So part of this, what I'm trying to do is get people to collaborate and work together and help me design things. And I wanted to keep us on track a little better with somebody that's just jumping in or jumping out to know what's going on. And so I've added this current goal down here at the bottom. And what this will do is just keep everything focused. We'll know for sure that like this is the thing that I am working on right at this moment, that the Inicus project is working on right at this moment. I've also included the chat in a box here as well. So the little box below my image, you'll see chat stuff show up in there. So let's just do a test message. Say hi if you see. There it is. Cool. So that way, in the replays, when I show this, when I put this on the archive channel or something like that, the chat will be there as well, because people give me ideas. People give me ideas when they stop by and see what's going on here. And I think it's important that those of you watching this replay after the fact see that where those ideas came from. So that's what that box is for. Oh, thanks, Bitamy. It could probably be a little better. This is just what I could come up with in a few minutes of time, but we'll see. We'll see what I come up with over as it evolves. So yeah, that's a good start. Any other housekeeping things? Oh, down below in the About section on this channel, you can see a link now for the GitHub. There's also one on the website, and if you go to that, it will take you to the Inicus project GitHub page where you can see all the project files for everything I'm working on in their current states. So feel free to download them, modify them, use them for yourself. I don't have any restriction on that right now. At some point, I'll start saying open source license of some sort. But my full intention is that anything on there can be used either... I intend for anything on there to be used either for hobby use or even commercial, as long as you just say where you got it from. That's all I care about. So, otherwise, feel free to use it as you wish. Or give me suggestions, help me out. I'm perfectly open with getting more collaborators. So, all right, let's get started then. As explained, these lights are running about as fast as I think they can go, which is really disappointing. Let me go here, and I want to, this looks a little small on that preview. I wonder if I can increase the text size. Give me just a second here. There's definitely a way to turn on like dynamic increase of the text size. So file color scopes, quick list. Maybe it's an editor. Let's go general. Yeah, here it is. Change font size with control and mouse wheel. Okay, let's apply that. And then I'll increase this a little bit. And that makes it a little better. So if you have any suggestions or just things you want to note that you think would make this better, absolutely let me know, because I'm all ears. Okay. So we'll get started, and I will just go through this as usual. And if you have any ideas or suggestions or questions, please ask, please comment, please let me know what you think I should do. I love accuracy by volume. So if you think your idea is if you're not sure if your idea is good or not, or if it's really bad, throw it out anyway, and I'll let you know. Or maybe the rest of the chat will. But I want to hear everything, because you never know. You might have something that you don't think is that great, but actually turns out to be pretty awesome. All right. I guess the first things first, we had to figure out why this is running so slow. As we can see down here in our console, this is the response, this is the response to the communication being sent to the device. And there is a lot of it, which makes sense. For every single one of these LEDs, there is a packet being sent, which it has to respond to. And then when they all update and switch colors, there's a packet as well. There's 30 LEDs on this strip, so you have to send 30 packets to update them all, or to change all the colors, and then a single packet to cause the entire strip to update and flip to that new color. And so what I'm doing is I'm doing that as fast as possible, and that's what's causing this this look of the LEDs cycling through. I'm really just changing all their colors as fast as I can. However, I wish it was going a lot faster than this. So, yeah. I was thinking through this some, and this might be a lost cause. We may not actually be able to solve this. And actually, we can do something right now to figure this out. We know that there's 30 LEDs. So how to do this math? We need to figure out basically like how much time it takes to send a single update cycle. If there's 30 LEDs, we know that from our packet, if we go in here, no, actually we probably won't have an example of it in there. Let's go back to our Python script and look up here. Here we go. This is where things are being sent. We're basically sending the address as a hex code, a semicolon, the color is a hex code, so that's 6 hex digits or a 24-bit value. I apologize. And then a single new line character. So if you do that math real fast, 3 plus 6, 9, 10. So that's 10 characters per packet that's being sent. And then this thing has to send 2 characters back, the K and then the new line. So if you think for a single pixel to change, you have to send 2 or send 10, receive 2, so that's 12 total. So, and that's pretty much accurate of every packet. So we can do a quick math thing here. We know that we can send 115,200 bits every second. But we need to divide that by how many bits are in a packet. And actually, we probably need to do that for our part first. So we know that there's 12 characters, 10 going, 2 coming back for each. And we know there's 8 bits per character, because a character is basically a byte. So that's 96. So there's 96 bits going for every single packet. So let's store that. And then take 115,200 divided by our value that we just got. Oh, I messed that up. 115,200 divided by, let's go to our memory, sorry, this equals 1,200. So we should be able to send 1,200 packets per second, assuming no lags or delays. Obviously, that's not perfect. This is the perfectly ideal situation, which is not going to happen. There's going to be a short pause after something is sent before it returns, before the response comes, and so on and so forth. Then we know that there's 30 LEDs on the strip, and then a single packet for an update. So we divide by 31, and that gives us 38. So we should be able to get a refresh rate of 38.7 if in an ideal scenario per second. That's annoying because this is running at 3. And I think even so, if we take into account the fact that this is not a perfect scenario, there are going to be delays in processing and time like that. The communication is still the slowest part, and I figure we could have that. So divide by 2. I figure like worst case scenario, we get around 19 to 20, which is still not happening here. So which makes me think there's got to be some way we can speed this up. So let's see. We got to figure out what's causing the slowdown. I changed some stuff in here which may have affected it. Let's go to our command parser. Buffer. There's a lot going on in here, but it shouldn't take that long. The chip's running at about 16 megahertz. So it's not that... it shouldn't be that... it shouldn't be that slow. I apologize for the way I talk. I talk with a lot of pauses and uhs because I'm thinking as I'm speaking. And it just... Unfortunately... It's not an asynchronous process. My brain has to think at the same time as controlling what I'm saying, and I can't do both at once. Alright, so I wouldn't even know really where to start, but we know this is happening in fast mode. Maybe we could just go to that function. Here's fast mode. Fast response. Update. One of the users had the idea of taking out these responses, and I think that's actually a very good idea, at least in fast mode, right? Because treat it as like almost a UDP protocol style rather than TCP, where there's no acknowledgements. All right. Well, no idea here what's taking super long. We did change something though that caused it to go really slow. But we'll get to that in a second. I have a feeling it has to do with that somehow, though. The communication back and forth. Let's, I tell you what. First things first. Up here, when we display colors fast, we're printing the acknowledgement that we get. I mean, even on a PC, printing to the console takes time. So let's go ahead and just stop this. You'll see the lights stop running now. So let's just read the acknowledgement like we need to, but not print it to the screen. That'll make the Python script run a little faster, although I don't know if it's going to be noticeable. Okay. No, not really noticeable. You'll see it come up here in just a second, but... Still running about the same speed. There they come. Okay. Let's just take it out entirely then. All right, so I'm going to do the thing I just talked about where I go in here and basically remove this fast response. All right, so that's the... Right. Okay, that's the acknowledgement for that. It's up here. That's the update. We can take that one out. Okay, really just those two, I think. Oh, and this one. Wait, hold on. I think I might be missing something here. I'm trying to think through this, like every section, like why it's responding there. So if we say, so this while loop, where does that end at? This one, okay. It seems like there's an extra response going on, which might explain some of this. Well, we're going to take them out anyway. Let's just take them all out, and that's Python. Okay, so basically we're going to send commands, and I did it up here too. This is going to be bad, switching back and forth between Python and C the whole time. All right, excuse me. So we want to write the fast response for getting into fast mode, but then after that we just want to let it go. And that should be good. I think that'll work. All right, let's verify. And then we need to stop our Python script. All right, and then we'll upload this. There we go. And let's try the Python script again and see what we get. Hey, that's okay. So it had something to do with the serial communication. That's way faster. It's still noticeably blinking, so it's not like, it's not perfect, but I think that's probably about reasonable as far as we're gonna get. I'm looking at it on the camera here. Excuse me, just a sec. It looks like it's almost running backwards for you all. That's because there's some sort of frame rate like desync happening. But trust me when I say it is blinking super fast. Okay. Let's see. What is next? Bit of me, are you still on here? Maybe not. All right, I think that's good. I think we'll stick with that for now. That's pretty much where we want to be speed-wise. I wish I had a way of measuring it. I could if I had a logic analyzer of some sort or an oscilloscope. I could see how fast it's cycling. But, well, actually, you know what? I wonder if we could time it by just saying like how long it takes to do like 1,000 or something. Here's our loop here. So let's do limit equals 0. And while limit is less than 1,000, we will go down here. We need to increase the limit. It's 1. Okay. So this will run for 1,000 and then stop. I think, oh, this might need to go back. Hold on. Oh, no, that's fine. Okay. So let's try that, and then I will stopwatch it on my phone, and we'll see. Maybe we can figure out exactly how fast this thing is going, because that would be really cool. All right, wait till it to stop. 1,000 may have been too long. I might be a little optimistic there with how fast it's running. Yep. Okay. That's all right. Let's drop it to 100. And then we'll start the lights again. And this way we'll see, I'll time it for 100 and we'll see what kind of refresh rate we're getting. $102.71 seconds. Well, that's pretty good. Where's our calculator? Actually, 100 divided by 2.71. So we're getting a refresh rate of about 36. That's good. That's really, really good. I was hoping for 60, but all things considered, that's probably about the best that we're gonna do. Maybe in the future, if we get some better hardware, I can come up with something faster. But for the moment, that seems to be about it. That's okay. 38 is great. Or 36 is great. I can work with that. That'll allow us to make some really cool displays and whatnot. Okay. So I guess that's that for that goal. We sped up the refresh rate the way we intended to. Oh, excuse me. I had chimichangas for lunch. They were delicious. In case you were wondering. So let me modify this real quick. I wonder if I can do this on the fly, because next thing we need to do is create the library, the Python library. And I don't know if this will let me change it on stream. Current goal is build the basic Python library to control. Let me move this. I'm probably running way off. I am. The Neopixels. Okay. There we go. Lock that in place. Can I modify the properties of this while it's locked? I don't know that I can. Oh, I might be able to. That's weird. Okay. Well, that's cool. I can modify that on the fly. So there's our current goal now. We're going to switch over here to Python. And what we need to do, we have this running in a main script, but we need to create basically a set of files, a library that can be used to control this and hides a lot of the details and quirks and things that the user doesn't want to bother themselves, or the developer doesn't want to bother themselves with. So things like the baud rate. Every time you open a port to communicate with the lights, with the device, you have to specify how fast you're communicating. And as I said before, that bit rate is 115,200. It's a set standard bit rate that is used by serial ports on computers. And there's many you can do, as low as 300, as high as 2 million. That just happens to be the one that this chip supports. But if it's always going to be that way, then there's no point in having to make sure that any developer using this has to figure that out on their own. Instead, we write a set of functions as a kind of in-between layer, and the function is maybe just start communication, and the developer just says, okay, start communication. And then our library knows, oh, well, the communication rate is this, so that's what I'm going to use to open the serial port and whatnot. And really, the developer all he has to do is tell us what port that he's on. And everything else is taken care of, all the initialization and everything. So I think, so that's the point of that. I don't know how much stuff we really need to hide, or how much easier this library will make things, but we'll find out. And I don't actually know how to make a library in Python 3. I did it in Python 2 a lot, but I'm going to Google this real quick. Let's see, create library. All these modules are basically just another Python file, but sometimes they're usually in a folder, and sometimes there's an init file, from what I remember in Python 2. That init file just allows you to run some code and set some things up when they import the library. So I don't know. We might be able to just avoid that for now, or do that later. This thing I'm looking at is just basically that. Yeah, well, maybe we'll just do that later. All that init stuff later. For now, we're just going to add a new Python file. And we're going to call this one, what should we call it? Lighting, well, we should probably name it in a more Python way. Let's call it lighting controller. All right, here we go, lighting controller. If I go look in this over in my file structure over here, yep, it's in that same file. So now here in main, we can basically just say, as another one of our import statements, import lighting controller. And then it will go to that file, and any functions we make or any classes we make will be pulled in. It's also worth noting that any code you put that's not in a function or class that's just run as main code that exists there will run when you import it. So you shouldn't. That's why we do something like this down here. You notice that all the main code in this section, or at least most of it, I put if name equals main. And what that means is if this script is run as the main script, nothing else is calling it, then it will run all this code below this if statement. But if I import, like if I were to run lighting controller as the main and do import main, then when it imported, it would see that, oh, this one is a called file. It is not the main file. And therefore, I'm not going to do any of this stuff down here. However, I did make some global variables up here, like this code right here that's not in a function. It's just global. This would still run. So because of the main file, that's okay with me. But in lighting controller here, we can't be doing that. Right. Then we need to move our serial stuff here. So import serial, and we probably want to import time as well. Actually, I don't know that we'll need that. All right, and then we're going to make a class, and we're going to call this one the lighting controller. And let's just go ahead and do our constructor as well. Oh no, sorry. I always forget how to do this in Python. Fine, init, self. Okay. We probably this will take some iteration. We're gonna have to design this, go back, think about it, redesign it some, because I'm sure I'm thinking of some stuff in my head about how I want to do this, and I'm sure some of that will turn out not to be the best way. So we'll need to go and figure that out. All right. I'm going to go ahead and put some optional arguments. Port equals none. And length equals none. Oops. And what's one more thing we would need? Starting color, maybe? Color equals none. Okay. We probably want some constants that we'll have to define as part of this. Okay, so color equals none. All right. And then we're gonna need a serial port as well. So self dot ser equals serial. Oops. Serial dot serial. It's the base serial class, and then we'll do baud rate 115,200. Everything else, all the other settings are normal, other than the baud rate is kind of a weird one, and then the port. We have to specify the port as well. If port is not none, probably want to do set port, right? And do port. Okay. So that starts up our serial class. Oh, that's not what I wanted. Sorry. Okay. All right, self to serial port. So we know our baud rate. What are some other ways we can define things? We might be able to define stuff up here. This, I don't know a lot about Python standard styles. Let's see. It's gonna have to be self.baud rate. That should work, right? Yep. Okay. we'll go down here and do color constants. And I'm actually going to go back here into the main and pull all these colors that I did earlier. Oh, is that really a thing? I just realized that the font on that was really tiny. So, sorry about that. I didn't realize that when I increase or decrease the font, it does it per, like, by file. I thought I would just do everything. Try and get this as big as possible. Okay. So that looks good. Now, if they have the port, we want to set the port. Otherwise, I guess we don't do anything. I guess, so we probably need a begin function. You know what? All of these things are going to have to be port equals port. All of these things are going to have to be saved. So we might as well just save them into class variables. Length equals length. Self.color equals color. So now you can see each of these passed in arguments are getting saved. And then we can do if self.port is not none. Then we set the port. Okay, that's probably all we need to do on init. And then what I'm actually going to do instead of trying to initialize everything in here is define a begin function. And begin is basically going to take in all of the arguments that we've already gotten and start the serial port, open it up, and you know, do whatever it needs to. And we probably, there was something I was thinking about that I wanted to do earlier that I'm going to add here, which is, let's see. I want to, there's something I've done in the past where if I didn't know the port, the serial port that I was going to use, but I knew that I would get some sort of start message, then I would just loop through all of 255 possible serial ports, try and open each one and see if I got the start message. And if I got that, then I would know that I'm good to go. If I didn't, then, or if the port failed to open, then I just tried the next one. So let's call it auto detect. And we're going to set this to false. But you can call it and say true as an optional argument. And then if so, it will try and detect the port on its own. Okay. There's that port, yep. I've just got to think through everything, understand what I'm doing again. Apologies for any time that happens. Oh, you know what we probably want to do? I noticed this the other day when I was working on this. When this thing starts, it sends a message back that says ready. And I noticed that it wasn't. Where would this be saved at? Isn't the main? Yeah, it wasn't in brackets. Well, I guess these aren't in brackets either. I guess that's not necessary. Okay, never mind. That's fine. I thought about putting those responses in brackets just to kind of make it a little more structured, but I guess it's not really necessary here. All right. Let's see. So if auto detect, then we want to loop through and try and open every single port. But first, well, I guess we don't need to know what the port is. In that case, it should work. So detected equals false, while detected, actually while not detected, What did I do wrong here? Oh. Detected as false. And then we don't have a not in Python. You have to type out not. While not detected. We're going to try every single serial port. Self.sir. Is it open? Yep. And we're going to specify, we have to specify the COM port first. So we got to do this first. Self.set port. I might have done this wrong, actually, than how I need to. Count equals 0. Actually, we just say 1. While count is less than 256, because I think that's how many ports there are. Say com plus string count dot upper. Wait, it's a number. I guess we don't need upper. Okay, so what this should do is loop through and create the text, because when you open the serial port, you have to specify to the OS, at least in Windows, a text thing that says COM and then the number of the port. All right, so we'll try that, and we want to do try. And then I don't actually know what the exception is if the port doesn't exist. Let me try and find that out right now. What are the exceptions? I apologize if this seems slow, but it's worth it. Taking the time to do this right will help us a lot later. So once again, if you have questions or thoughts or suggestions, please let me know. I'm looking up the exceptions on the side over here. Constants. Where's exceptions? Oh. Oh, it's just serial exception. Okay. Try that. Except serial exception. Whoops. In which case we just want to continue. Else, if it does open it, then we want to try and read it. So result equals self.ser.readline. And I guess we need to set a timeout if we're going to do this. Set. Is there a set timeout? No. Timeout equals 2. I'm giving it 2 seconds. I think that's, well, probably a little, maybe 3. I think that'll be enough for it to start with. Reline if result equals, I guess we are going to need our variable now that I'm thinking about it. Detected equals false. If result equals ready, then detected equals true, and break. Okay, so we'll break out of this while loop if that happens. Otherwise, oh, we need a second equal sign here. If it does not equal ready, then it will try again for the next port. And if we get all the way to the end and we haven't found it, then detected will still be false, and we can see how that works. Or we can use that. If detected, or I guess if not detected, return false. Something went wrong. Okay, that's all fine. Now, here we can close that. And we want to also see, like, okay, so if the auto detect is still false, then we don't need to do that at all. We just need to open the port according to the current settings. self.ser.open. Okay. And then after this, we need to actually go through and initialize everything and begin the communication. But this first section was just detecting if that port existed. I'm not sure how, like, I don't know how robust or good this function is to use, because going through and trying every serial port just doesn't sound necessarily good to me, but let me add some comments. Whoops. Just going all over the place right now. All right, port found. Check if correct. Didn't find the port. Set attempt variables. To open the port. Okay. Very good. It's all looking good over here. Next. For this one, we just want to say open with user specified settings. And then I guess it's still possible in this scenario for the user to not specify the port. And if that's the case, we probably want to bail anyway. The user is at some point going to have to, yeah. If self.port is, we have to check, we have to allow for that. So if self.port is none, this should probably be its own internal function now that it's getting this big. Return false. Otherwise, open it. Okay. And then I guess we also need to verify the length and color too as well. If self dot is none. I guess color's not that necessary. We could just use black. Black. But the length, we don't know that, and that's a risky one because electrically that could affect things. So if the length is wrong, we want to just exit out. I'm actually going to move this down here because I don't want to set that until everything is correct. If necessary. All right, if self.length is none, then we want to return false. Okay. So that's a pretty good start. I'm going to move all of this logic to a different function. Yep. Detect port. Yep. All of this needs to go. Okay, and all that looks good. The only difference being, okay, we should be able to return. If we found it, we need to return true. Okay, so that looks good. And then up here, rather than just if auto detect exists, then we just call that function. So result, or let's just say if self.auto detect port. Actually, let's say if not, then we return false. All right, there we go. What does this have a thing for? Function name should be lowercase. Really? Okay. Thought I wanted kind of a camel case style, but I guess not. All right, assuming all that goes well, then the next thing we need to do is actually initialize everything, which means a couple things, which you've seen here in the main, I believe, is we basically need to send the init command with the length and the starting color, and then send the update, and that should be it. That should be enough to get us going. So I can take both of these, and I might have to mess with this a bit. Length. Oh, and you know what? If we open the port with the user settings, we still need to do this, check this result. So up here we go. Open port. Check port. All right, and then we will get a read line. Read line. Okay, and then we need to set that to result. So if result does not equal ready, then we need to return false. And this statement is useless. All right. So then if our port doesn't respond with ready, we know that it's the bad port, it's the wrong one, and we probably need to close that as well. I was just thinking about that. Like any ports that we open that don't end up working out, we definitely need to close them. Okay, there we go. Okay, now, so we've created a function that's going to loop through and try and find the correct port for us. And we are going to close if necessary, but hopefully we find it. We're good to go. And then we can go down here, and we need to start initializing. I think I copied this from here, but I need to recopy it. We need to go through and do the main. Do the actual thing that we need to do to make sure this gets set up correctly. So let's just leave this here as a reference, and let's make our command string. Command equals, and then we'll take this first part init semicolon, or I guess that's just a colon. Init command, and we need to do hex length. And actually, we've done this before, so let's just go ahead and pull that from anywhere in here that we've done it. Here, there we go. So this whole string is what we do, and actually we should probably just have a function for that. Define create hex value. Number characters. Characters being the number of characters that should be in the final value, because sometimes they do, sometimes the program will care. We'll say 2 is default, but sometimes it'll have to be, actually, you know what, we should force the user to specify that. All right, and then we'll put the number here. Characters will be here. So we'll create a hex value. We'll strip off the 0x from the front of it. We'll strip off the L from the end if it's a long value, if it turns out to be really big. And then we'll specify the number of characters and pad it with zeros if necessary. And we'll return that. So then we just say return, or not return, dot create hex value, and we want the length. And we know that this is going to be 2 characters. Maybe it should be longer. That'll be okay for now. Okay, and then we need to add the comma. And then we do the same thing with the color. So init command equals self.create hex value, self.color, and we need to specify this to be 6 digits. As you can see here, RGB values in hex have 6 digits, so that makes sense. I think the way we've written our program, it won't actually matter, but it's good to do anyway. And then we need a new line. Because that's our command terminator that we've picked. Okay, so that creates our command, and then we just write it here, and we say bytes because we have to convert it to bytes, and then do init command. Okay, and then the read line, we just need to read. Also, we need to make sure that we do that correctly. And we should check at every point here for sanity's sake. So readline, and if result does not equal command received, then we'll return false. And we should probably close the port in that scenario. Okay, and then we need to update the pixels as the final thing. And we can see that here. We probably want to just go ahead and define that as its own thing. Constant commands. And we'll just say update equals that. Okay, and then we'll go down here. Oops. Self dot update. Cool. And then we'll want to check this again. Same thing we did earlier. Check the response, verify that we got the thing we wanted. result equals self dot insert a readline. Okay. All that should resolve out. Okay, good. And then assuming all that works, we should be good to go. So we can just say success, return true. All right, one more look through the logic. Just make sure we didn't miss anything. If we ever return false, let me check this function too. If we ever decide to return false, we probably need to close the serial port if it was opened. So I think we do that in every scenario. Whoops. Okay. Weird. All right. That looks good. All right, now we need to have functions to update these, because we didn't force the user to specify these things, so we need to specify them later. And that means checking that, just doing certain sanity checks. Yeah. Yep. I'm going to actually... I'll change this in just a sec. Let me just define these right below here. I think the standard is that you should have your functions in alphabetical order. I will maybe get around to doing that at some point, but I tend to just define things as I'm writing them. So... Or like just put them as I'm writing them next to each other. So set port... Port dot port equals port. Set length. This is the one where we'll want to check something. And then, so we're going to want to set a max. Equals, and I think we decided 255 is probably the max. At least here. If length is greater than dot max, then the length equals self dot max LEDs, and self dot length equals length. Oops. Okay, so that one checks our length, and then finally our color. Set color. And then we know this needs to be a 24-bit value, so we'll do a double check here. We'll do self.color equals ANDed with color. We'll say bits 24 equals this value. And we'll drop that here. Just having it as a constant. Okay. Excellent. So now, we know, so now we have all these functions now that the user can use to set these items if he doesn't do that immediately, or he or she does not do that immediately. Otherwise, they can set them here. And then we need to take advantage of these checks that we just made. And so we'll do, let's see, self.port equals none if self dot, or if port is not none, self.port equals self.set port port. Okay, so what this does is first checks if the or first sets the port to none. All right, so it initializes that variable. Then we check if this value up here is none or not. If it is not none, then we know the user supplied a value. Then we set it based on this right here. I think that'll work. Is there anything that, there's nothing that returns false right there. Yep, okay, that'll work. That'll work just fine. So that port doesn't return anything. Oh, it doesn't return. It just sets it so we don't have to do that. Okay, cool. Value. All right, then we need to set the length value. This is always the fun housekeeping stuff when you're just going through and making sure your code is very robust. Length equals none. And then if length is not none, okay, and then set color value. And we gotta just do the same thing, and I'll actually just copy this and change all the names. If color not done, set color to color. Okay, so now we have all the functions there to set our variables, and wow, we've done all this just to get this thing started. And then finally, I think also, just in case, we should have a close function, or an end function, basically. And this is just the close the serial port and end communication. All right. I got comments on all the big functions. Let me just make sure though. Number of Neopixels. Color, the initial color. I guess we should test this and see if it works. Starts communication and sets and shows the initial color. Converts a hex value to string. You know, I think now that I'm thinking about it, I don't know that I used that bytes function correctly. I think I have to specify the encoding. To auto detect the port. All right, so we should test all of these functions before we go any farther, because there could be quite a bit of debugging. I believe I did a conversion up here to bytes at some point. Yep. Bytes, yeah, we have to specify the encoding for using that bytes function, so. Where did we use that again? Bytes, here we go. All right. Any other places? Nope, just one result. All right, cool. All right, so now let's go over here to the main. Ignore all of our existing functions. Import lighting controller as LC because I don't want to type that every time. And then let's go down here and we're going to do this thing that we did before where we took all this code out. Actually, let me just throw it up here. And then drop down here because I want to uncomment these blocks separately. There we go. Now we can just close these. All right. So we need a controller. So controller, just call it con actually. equals LC dot lighting controller. And our port, we're just going to test everything test it as if we know everything already, just because that seems better. Length equals 30. And color equals I guess we just need to specify a value. So let's just do white. All right, and you should see it here when it lights up. These lights should all turn white. Okay, maybe that works. Let's. Oh, and then I'll have to call the begin function. Dot begin. I hope this works. Nope, there's an error. There's always an error. Permission denied. Permission denied. Something's already using it? There's nothing running. Huh, interesting. Okay. I wonder if I didn't kill something correctly or whatnot. But basically it's behaving as if the serial port's already in use. So I'm going to unplug that and plug it back in. And we'll try it again. Could not open port COM4 permit access is denied. Interesting. So it did work before. All right, where's this happening at? Line 92. So after we verified pretty much everything, interesting. And we set the port up here. Well, it wouldn't be fun without a little bit of unexpectedness. Let's see here. I'm just trying to think, why would this be? Let me search this. Maybe the internet knows. Let's see if any of these forums can help. So far, the first one was not helpful. Let's try and do the auto detect and see if that changes anything. I don't think it will. We can take out this, our parameter, and it will know, and then we can say auto detect equals true. Did it move maybe? I probably should have put something to say like where it's at. Oh shoot, you know what? I do this all the time. I bet you in my auto detect here I'm not incrementing my count. Where is it? Here it is. If we auto detect, yep. count plus equals 1. Let's try that again. Could not open port COM2. System cannot find the file specified. Well, that's because there is no COM2, and apparently I didn't catch that. Where did it throw that error from? Nope, not there. Here. Oh, weird. So when you try and set the port, that's when it tries to open it. Okay. Oh, no. Hold on. Wait, yeah. That's odd that that function tries to open it. It doesn't, though. I bet you there's something going on here. It should have done... Well, it didn't do that for COM1, but that kind of makes sense. Maybe I need to close it here, as well as if it's not detected. Alright, let's try that. Same thing? Dang it. I might not be able to use this function for now. Alright, let's debug that later then. Let's figure out why our port is not showing up like it should. Oops. Such is the life of an engineer. Constant figuring out what went wrong. Oh, I guess we need to actually begin. I must be missing this, but does set port open the port itself? I wouldn't think so, but evidently... Oh, wow. I didn't realize this serial port library had a bunch of... Oh, that's weird. It has some threading stuff built into it. That's kind of cool. Oh, it's implementation. Right now, it's currently in experimental state. Use at your own risk. But that's cool if you want to read things asynchronously. The set port function doesn't tell me that. So all I can assume is that when I get to somewhere down here, because I've already set the port, it's already technically been opened. In line 92 and begin here. That's kind of weird. I never realized that about the serial library, if that's the case, which is why I don't think it's the case, because it just doesn't make sense to me. Why is access denied? What is using it? I don't think I'm using it over here. No, this isn't open. Is there any other... There's no other... Nothing's running in the background that would make use of this port. Alright, this is kind of annoying, but it happens. I guess we gotta see what... What would be causing that? I mean, it seems pretty straightforward, right? Access is denied means that likely something else is using it. But I can't find what else could possibly be using it. Nothing's running. I've unplugged it and plugged it back in just to try and reset it. Just do a double check here on my device manager and make sure that it's there. Yep, COM4. Oh, dang it. I knew I was going to do something like this. It's not that. It's that this line up here, I'm already opening the port. So, gosh dang it. Yep, that was my fault. It happens. Simple mistakes. Alright. We might have introduced some error with those random closes, but we'll see what happens. Port must be configured before it can be used. Before it can be used. How is it not configured? I wish it would tell me exactly what is not configured. It should have the baud rate, and it should have the port already, which should be everything it needs. So maybe there's something it didn't get? Did I didn't mess anything up here, did I? Other than all of these functions. We should probably just comment all of this out, actually. And then all the way down to here. There we go. So we configured, so we gave it the link, gave it the number. If we go here to the init, serial baud rate equals baud rate. Is there a set function? We could set the port. Can we set the baud? I guess we could do that up here. Say baud rate equals 200. And take both of this out. Did we define a constant up here? We should probably, yeah, we did. We should probably make use of that. And then anywhere else that it's at probably isn't necessary anymore. I don't think it is anywhere else. All right. Is that it? Nope. Port must be configured before it can be used. All right, let's Google it, see if I made a common mistake. See other people having the same problems that I do. Is it a closed thing? Can you not close it if it's not open? Those of you that are sticking around for this, I really appreciate it. I know this can be a drag sometimes, but such is design and figuring all this out. Let's see. Why would that be a thing? Because we do configure. We include the port and the baud rate. Is there anything else that those are usually just the standards? Pretty much everything else you can leave because it has a default value. So let's try that, see what happens. Okay, supposedly that worked. It didn't actually do anything, but it didn't throw an error that time. So for whatever reason, when I... Oh, that's weird. Whatever reason, when I set the port later, it's not actually setting or something? Close. I feel like this function call right here is not valid anymore. If you have any questions or suggestions, please let me know. More than happy to chat. It sometimes helps me think too and figure out what's going on. Let's see here. Yep, allow access there. I just want to see. Sir. I just want to see the actual. The baud rate is set. You can see that set right here. What about the port? None. For whatever reason, when it gets here, the port is none. Am I not actually setting it? That would probably be what I'm doing, because that I would not put that past myself. Self.port. Yep, that sounds about right. That would be it, wouldn't it? Open, got an unexpected keyword argument port. Dang it. Self.sir.port equals self.port. Fine, the open function can't have a port specified. Okay, that worked kind of. It just didn't. But that's okay. For whatever reason, I don't think it reopened. So it didn't turn the lights off like I was expecting. That causes a reboot. So just for sanity's check, just to see. Let's make them blue. So you should see the lights turn blue. Nothing. Okay. So something is wrong here. Either the strip is stuck or something. Let me unplug them and plug them back in. Give them a second to cycle. There we go. Now let's try again. And once again, we'll do blue. Oh, they were probably working fine. I just didn't do the update. No, they're not working fine. No, I've broken everything. Man. No, I didn't break it. I forgot. I did this wrong again. Commas. I always forget that I have to use commas there. Command received, and then update. There you go. Now they're blue. Okay, so sanity check. The lights are working. I forgot the closing bracket here. That's what I've done. All right. Try again. Nothing. All right, let's debug and see what init command looks like because I'm messing something up. Init 1E202020. I don't think uppercase would matter, but maybe it does. We could do that. See what happens. Okay, so that looks correct. Then what about our update? That looks correct as well. And it should be turning like a not too bright of a white. So what am I missing? Because that seems correct. Let's just drop it there as well. Whoops. Oh, return false. It didn't receive command received. So it's not updating because it doesn't think we're getting the right thing. What did it get? What was the result? It got command received. Does this have to be bytes? It might have to be. Yep, it does have to be. All right, I'm going to make some constants then. Because that makes some amount of sense. So command received equals this. Copy value. This way I don't have to type it out every time. Oh, we're so close. We are so close to getting this to work. All right. Hey, it turned white. All right, finally. Ah, and all of that was just to set up the initialization for that function. How's it going, Beth? We've been headbutting and trying to figure out errors, but we just fixed one, so that's been good. What do you think of the new layout? I decided to update the layout here to show a little more just I guess just organize things better. And I wanted a current goal down there so everybody would know what I'm trying to work on at the moment. So let me know what you think. Let's see. All right, so that's done. So I guess we got to figure out what we want to do next. The dark screen is easier on the eyes. You think it's too bright? Is the blue too bright? The blue background? Or are you just talking about the programming screen where I'm writing the code? Oh, you're talking about this. You're talking about this one right here. Yeah, I get that. And actually, you know what? Now that you mentioned, I'm glad somebody is giving me feedback on things like this. I think there is a dark mode. Here we go. Default theme requires. Oh, it's just the default. I bet you I can install one. All right, we'll come back to that. But yeah, I think I remember seeing before that there's a dark version of it, like this one here. Yeah. I've also, if you noticed, anytime you chat, there's a little box. There's a gray box below, or a black box below where my camera is, and chat stuff shows up in there. So it'll show up. Anything you type now will show up in the YouTube videos as well that I put on the archive. All right. So what else do I need to do now? So I think I've proven this part works. So I guess next thing's next is I really need to manage the length and or the length, all the array of neopixels, right? Let's see. I probably need a function for creating the buffer. Since we're not really limited in memory on the computer, I'm just going to make this max. Yeah, it's definitely easier on my eyes. Especially helps with these, I have these bright lights that I'm trying to look around the whole time. It's nice to have a dark screen. I've also made the font bigger too. Hopefully the font is a lot easier to read now. Okay, so let's store pixel colors. List equals that. Should probably make an old list as well. This is going to be part of my master plan to like limit the number of limit the amount of communication that's happening. So for example, if not all of the colors are changing on all the lights, like right now, we have to send a packet for every single light, even if it doesn't change color. That's just the way this is set up. And so, or with our test functions. So I want to make it so that if I tell it to update to new colors, it will go through and figure out which ones haven't changed and not even bother with those. Because there's no point. All right. Equals 0. While count is less than self dot max LEDs. Actually, we probably don't need this one just yet. Black, okay. And then count increment, and then finally return new list. All right, and then up here, when we start, we'll go ahead and make our pixel buffer. Self dot pixel buffer. Yeah, that's fine actually. Self dot create pixel buffer. Okay, cool. And that's going to initialize it with black. And then we need basically, I guess initially we're going to need a function to change the color of an LED, and then a function to update it, to send out the update command. Later, we're going to want another function to enter fast mode or leave fast mode, and so on and so forth. So, yeah, let's try. I think we can have time to get all of that done now that because a lot of what we're going to be doing here is stuff we've already done, so we might be able to get through it a little faster. Here, let me close that so I have some more room. Yeah, let's just get to it. Set pixel color, and then we need the pixel and the color. And so we'll do if pixel is greater than self.length, and we should do greater than or equal to, I believe. In this case, we'll just return. We just won't do it. And color is going to equal color ANDed with bits 24, just to make sure the value is not too big. You know, if it's a little bigger than 24 bits, then we might have an issue there. So, okay, and then we basically need to go into our buffer and set that color. And then I mentioned earlier that I wanted to create an old buffer as well. So up here, we're pixel buffer self dot, we'll call it record buffer equals self dot pixel buffer. Actually, you know what? That's probably not a good way to do that, because I think Python, in those cases, it will be by reference. It doesn't necessarily make a copy of objects. So let's do create pixel buffer again, just do a record buffer. So basically, every time I update, I'm going to save the pixel buffer in the record buffer. Oh, the way I'm thinking of this, it should work just fine. We'll try it. And so that way, with the record buffer, I can then compare them with the new changes once I reset LEDs in the pixel buffer, and then I only have to send packets for the things that changed, not everything, because I'll have a record of what it was previously. Okay, so for setting a new color, this one's pretty straightforward. just self.pixelBuffer, and then at that point equals color. That's pretty straightforward. And then we need to define an update command. And this one is very special because, or not very special, but more complicated than you think, because we're not just sending the update command, we actually need to send all of the new pixels. All right. So just do count equals 0 while count is less than self.pixelBuffer, or no, it's length, Then we're going to go through and compare everything, and anything that's different, we're going to send a change command. So self.pixelBuffer. How do we want to do this? I guess we need to create a new command every time. So pixel command. Oh man, you know what? We probably want like a function that just creates and formats this whole thing for us. Yeah, I hate to just derail for a minute, but we're definitely going to want that. We'll just put a placeholder in here for now so that doesn't show anything weird. All right, we want the command and then a param list. Okay, and then we'll say new command equals, start with the opening bracket. I'm actually going to change this to a slow command. Actually, you know what? That's probably fine. Just create command. All right, so new command, command plus equals command. All right, then things get tricky. So let me go ahead and start adding comments so they know what's going on here and keep our logic straight. Creates and formats a new command to send. All right. And then, so we want to start with command, and then handle parameters. All right, so for x or for p in param list, and if it's none, there's no p, so we don't have to worry about that. New command equals p plus comma. And then new command dot rstrip, which is kind of a backwards way of doing it, but it's fine. Strip the comma off the end. New command plus equals bracket and new line, because that's our command terminator, and then return new command. Excellent. Okay, so now make it, man, it might be static. It probably is actually. Fine, I'll make it static just to make everybody happy. Okay, so pixel command equals new, or sorry, self dot new dot create. Create command. Oh, you don't need a self parameter in. And actually, I think that's right. Self.create command. And then I guess we need our commands. So let me go over to this. I have to go to the thing down here and figure out what the commands are again. I've neglected to write these down and I need to. I should have some documentation that tells me exactly what we're doing. Set 1. This is what we want to do right now. I'm in the wrong place again. Oh, I just wanted to find this. Okay, hold on. There we go. Oh, shoot. You know what I didn't do? I didn't return the bytes version of the command when I did that. So we're still getting the incorrectly encoded one. All right, I'll fix that in a sec. All right, we want to do the self.compset1. And then we need the color. Okay, I know what I'm missing here. That's fine. Let's get down here first and fix this. Bytes encoding equals, and then I think I have it in here somewhere. Here it is, UTF-8. Here it is. Excellent. Okay. Now here, I've already neglected to do this correctly because first I need to check if it's even changed. Self.pixel buffer at this point count does not equal self.record buffer at count. Then we need to do this. We need to create the command and send it. Oh, it's a list. Count self.pixel buffer. And then that is on the count. Okay. So that'll create the new command. And then I guess we need to send it. Since we're not in fast mode, we better get a response as well. Dang it. I think I just... I guess I should have a function just for sending slow commands. Well, yeah. Or return a value, but we don't necessarily have to use it. Right, command, and then result equals self.readline if result equals command received, return true, otherwise return false. All right, excellent. Now, command in slow mode. And that's pretty self-explanatory. Buffer is all pixels. Okay, so now we just have to call that here. Self.send slow command. Pixel command. There we go. And then count 1. And then finally, at the end of this, we need to call an update. So first we need to create it. And actually, you know what? I could probably have a function just for this. Show Neopixels. Because I imagine I'll have to do this quite a bit. Where this will create a command. I want that update one to be called com update. Here it is. Just so all the commands have the word com in front of them. Well, that's actually the whole thing. I probably don't even need to create it then. Yeah, that's probably good. Don't even need to create it. Okay, finally, new command. Or actually, we just want to send slow command. And I'm not bothering to check if it works or not, just because I don't think there's much risk right now. But I included that feature anyway, just in case. I decided that we should check it. All right, show Neopixels. Should just show everything. So then up here in the update, I know that I want to show them already. So at the end of it, I can just say show or self.show Neopixels. And then I need to remember update my record buffer. Record buffer equals self.pixel buffer. I'm pretty sure those are passed by reference though, so I think any point I do this, I might have to create a copy function. Which is kind of disappointing, but yeah, I'm pretty sure that's how that works, so that's unfortunate. All right. Now what? I guess we test it. All right, set pixel color. And let's just, so we had the strip here turning white at the beginning. Let's just set like the last 5 of them to red or something. So we can just do while, so let's do count equals 25 while count is less than 30. And then set pixel color count, and let's just set it to red. So we'll see the strip at the end here turn red. Then count plus equals 1. Okay. Don't forget your colons. And then I guess we need to update it. It's set pixel color. What's it called? This is going to update pixels. That's what it is. So theoretically, this works. So it comes on white and then immediately turns this section on the end here red. I don't see this working on the first try, but it doesn't hurt to give it a shot. Oh yeah, I forgot that I changed that. So it didn't even compile. All right, didn't work. What did we miss? Oh, I bet you, well, I don't know that this is the reason why, but let's go to our update function and figure out what didn't work. Or what is it? This one, send slow command. Let's just go here because if we debug, we should be able to see all the commands it sends. Got an update. Whoa, hold on. Yeah. And I suspect that's because up here, when we looped through and checked if it was different, at no point was it ever different. So if I go here, debug again, watch this, go self, and then we go to pixel buffer and record buffer. You notice that the ones we changed are already changed in both because it is, when every time I do record buffer equals pixel buffer, it copies it's a reference, it's not a copy. So we have to actually make different buffers and make like a copy function. Such is the life. All right. So we need to make a copy function. Copy to record buffer, I guess. And then for let's see. How about let's just do by count? We'll just do this the non-Pythonic way. Is less than length of self.pixel buffer self.record buffer at count equals self.pixel buffer. There's probably like a function in the list class that lets you just copy one to the other. I guess that would be the ideal way to do it, but for now this will be okay. Okay, and then anywhere where we do this, where we copy to this record buffer, we want to use this function. We can just drop it in here. Oh no, that's already where we're at. Here we go. Go and double check record buffer Okay, I think that'll work. So now let's run it and try it. We can close that. All right, better. We're getting closer. Unsupported operand types for int and string. Okay. Wasn't ready for this. I guess all of them. Ah, shoot. I don't know that I can necessarily just create a command. Easily. Because the parameters have different formats, so I might have to actually just do this manually. That's unfortunate. Okay, yeah. So that's a thing. Create command. Maybe we can get away with it this time. All right, create hex value. Here's our number, and we need our number of characters, and I'm going to do 6. And, oh, we can't call that in static methods either, so this is no longer static. We have to reference it as not that. Okay, there we go. Maybe that works. It still didn't turn the lights to red like I wanted them to. All right, let's go back to our send slow command and see what we're getting. Let's just debug and see what the command is every time we hit it. I don't care about this one. Set 1. Oh, we forgot the colon in our create command. All right, so new. Hold on. If, let's see, we need to add it here. If length of param list is greater than 0, then new command plus equals a colon. All right, so now if I run it, hey, there we go. The end of it turned red. All right, took a while to get there, but we got there. Let's start at 20 so we can just see the last, so it'll be easier for you to see. That'll be the last 10 pixels. So I run it again. There we go. So it turns the whole thing white and then turns it red. Just at the very end, because I told it for each pixel starting at 20 up to 29, set that to red, and then I told it to update the pixels so it displays them all at once. Supposedly, it did. It did seem to do kind of a thing where it looped back. It started from the end and worked its way back. Let's try it again. Maybe it's just. It looks instant to my eyes, but on the camera it looks different. Oh, maybe not. Okay. Well, that's cool. So we got our pixels running from this, and now we have a really cool. We have an interface in Python that allows us to easily set a color and update them, and it only changes the pixels if they have changed. So it doesn't waste time communicating things that are not different. Okay, what else do I need? I think we pretty much covered all the goals. That's a pretty good start. The question is what to do. So now I got to figure out if there's more commands that need to be added. Maybe there's more things that need to be added. Maybe we need to add gradients and stuff between, just different effects. Oh, you know what? We probably got to enter we still have to enter fast mode and everything too. We probably need to do that. All right. Something else to add, but we'll get there. I know we started a little late today, so I'm going a little longer than usual as well to try and get all this done. So as seen earlier, fast mode allows us to very quickly cycle the LEDs, but it's very limited. It only can do a couple of things. It just has less commands available to it. But I think this will be good. I gotta think about how I want to do this. I need a variable to track if I'm currently in fast mode. Fast mode equals false. Because when we start, we're in slow mode. But then once we up ourselves to fast mode, we got to do that. All right. So if fast mode is true, but we're already in fast mode, and self.fast mode, then we just want to return, because we're already in fast mode. There's no point in staying in it or trying to tell ourselves to be in it again. Else, if not fast mode and not self.fast mode, well, we're going to return as well because we're already out of it, so we're not going to try and get out of it again. Otherwise, the other two cases, we are not in fast mode, but we want to be. So hold on, first check if already in mode. Change mode. So if fast mode. All right, so we're not in fast mode and we want to be. Then we need to send a slow command, and we got to probably define this command above, because this will be one that's preset. All right, don't forget our brackets and everything. All right, enter fast. So we're going to want to do the same thing again that we just did, but demonstrate that it works in the whole fast mode thing. All right, exit fast. And this command is a different format because we're in fast mode in this scenario. It's just exit. Self.send slow command. And our command is enter fast. Exit fast. And then we also want to update our variable here to match with this. Actually, you know what? I guess we could just do it at the very end here. Equals fast mode. Update mode. Okay. Hopefully I can get this part done quick because my throat's getting sore. I want to... Oh, it is getting sore. I want to just get this done and move on. All right, so that should change our mode. And we can go ahead and do that. And just test that in our main real quick. Dot enable fast mode. Fast mode equals true. All right, and then if I go into send slow command and just drop it on, actually right here, we'll just get the result back and see what we see. All right, result equals K. All right, cool. Oh, interesting. We might have to do this manually because this is different than. You know what? Maybe we change that here. Because we already took out responses anyway, so that's technically a slow command. And so is the exit. It's a slow command because you get a valid response. So yeah, let's just change the response. Where is it? Command received. Is it here? No, that's just that library. Here it is. Command received. All right, I'm going to actually move these. Into the command parser. Because that just seems like a better place for them. And then we'll drop this. All right. And so basically we want to see anywhere that, or not anywhere, but that one spot where we respond to that. Well, excuse me. Parse, add, somewhere we have the fast command mode. Fast mode, here it is, fast mode, serial.write. Here we go, command received. All right. So we gotta verify this real quick and upload it. Can't open the device. Access is denied. It might be because we're currently using it. Let's try that again. All right, loading. There we go. And now we run this again. We should get the appropriate response. Command received. Cool. All right, so we'll be in fast mode. All right, then while in fast mode, anytime we do this, update Neopixels or set pixel color. Well, set pixel color doesn't change, but update pixels and show Neopixels, those can change depending on the mode that we're in. So I'm gonna first close this so we can see more. Take all of this code in here out and put it in its own function, update pixels slow. Okay, and then take all this, cut that, drop it here. Pixels in slow mode. And then we need an equivalent function called update pixels fast, which does the exact same thing, but does it for fast mode. And then here in this function, we need to go if self.fast mode, call fast mode, else self.update pixels slow. And then down here, we'll go ahead and add in our function. Pixels in fast mode. Ooh, excuse me. All right, so next thing's next, we're going to have to do a create command fast thing. Oh, this is going to turn into a whole thing of us digging through all our code to find the commands we got to change. Fast, and then it's just... Actually, this would only be one thing. We'll just do command and param. There's no change command for fast mode. We don't need to do a list because in fast mode you can only have one parameter and it has to be a number, because the only times you have numbers are if you're not doing an update command, which is auto-defined, or exiting, which is its own thing. That's already a slow command. So you have an index and a new value, color value. New command equals nothing. All right, and then we can go down here. All right, oh, that's a great command. And plus equals, sorry, create hex value command and 2. And then we'll just add on the colon and then same thing. Do it again. Except this will be the param, the color, and then add closing brackets and new line. No, not closing bracket, just new line. Forgot how that worked. And that's it. And then return bytes, new command, and encoding equals UTF-8. Okay. I'm just trying to think if there's anything I missed there. I think we're good. Okay. So then up here, update pixel slow, update pixels, we want to create command fast. And then we don't actually want to do this. Just want to do count and Yeah, actually this is correct though. All right, that should work. All right, and then we need to do send fast command. Which I guess that's just the same as just send. And in this case, we're not going to get a response, so who cares? Self.ser.write pixel command. All right, and then show Neopixels. This one we'll have to update as well with a fast and a slow. Souls fast. All right. Souls byte. There we go, and then just a U and new line. That's all it is for the update, because we're trying to make this as fast as possible. Self.write. Self.com update fast. Okay, and then this one is the slow version. Where we'll put this function. And then finally up here, do if fast mode enabled, self.fast mode. Excuse me. I apologize. I don't know why my throat's starting to dry out a lot, but souls fast, else show Neopixel slow. And then let's just add comments. Update command in slow mode. Sends update command in fast mode. All right, there we go. Is there anything I think I missed? Well, I still have this red line here, so I probably missed something. Oh yeah, update pixels. Self.update pixels fast. So now I should be able to enable fast mode and then do this exact same thing down here that I've already done. I mean, I don't think it'll work on the first try. It did work on the first try. Wow. Really? I'm stunned. Things don't usually work on the first try. Ah, I did get it wrong. Oh, no, I didn't get it wrong. Let me just go here. I need to find a way to see. Let's do it here. Let's debug. It'll be white. The whole thing will. Okay, there it is. And then we know that update fast is you. And if I hit play, then it just turns red? I guess it works. Wow. Okay. Cool. I think that's pretty much everything I wanted to get done today. At least that I had to get done. So that's really good progress right there. So I guess I gotta figure out what we're doing next. We could add some more like functions to control, or just add different effects and things that could be useful. We could test it out. I wonder if we should go through and um, oh, we got a delay command as well, but that's okay. That can come next time. I'm just doing some stuff here to do a more dynamic demonstration. All right, and then this should go in a while true. I might have to put a sleep in here. Just because this is probably going to go too fast if it's in fast mode. At least it should. I think it froze. We had this problem before where something was just running so fast that it just glitched out and froze. Yeah, it's got an error on the... That's a serial error or something. Okay. So let's do on each one of these time.sleep. And we'll just mess around with it and see how fast we can get this to go. So sleep time equals 0.1. All right, and I'm going to put that in here. So this is just some testing to see what we ended up with, what all our work got us. All right, you'll see it comes cycling through here. There it is, and then it'll come through blue. Look at that. I need to figure out how to get this to run like async. I need to get that file thing working so it'll just run when it's plugged in. And but that's cool. All right. Let's run it twice as fast, 0.05. Here it comes. It'll come a little faster this time. Yep. Going basically twice as fast. And we were having issues last time getting down to these speeds, so this looks awesome now. This whole no response thing is probably helping a ton. All right. 1/100th of a second? It's working. Oh, that's so cool. It looks awesome now. It looks so good. Let's try 5/1000ths of a second. I don't know if this is gonna be noticeably... Well, I guess technically it is twice as fast for us. Yep, there it goes. What's our limit that we have to wait? Fast mode is great. There you go, that froze. That had an error. Let's try 2. Half the speed. Seems stable. Okay. I think that's our limit. 2/1000ths of a second we have to wait between commands. Wonder if that has to be, if we should, Wonder if that should be built into the library somehow. It's obviously longer if you're in slow mode because the commands are longer, but... Huh, cool. Well, I'm satisfied. That was epic. All right, I think that's gonna be it for today. I got some stuff I gotta do anyway, and yeah. So let me know on Twitter or in feedback and comments on YouTube, or well, I guess I don't have YouTube videos on the main channel, but on Twitter or whatever. Let me know if you have feedback or ideas or things. I guess next time we'll want to experiment with putting some other useful functions in for gradients and things like that. Maybe not. Actually, you know what? This is probably good for where this part is. I need to look into the SD card thing, because that's kind of the next like major step, which would be the coolest part, which would be really cool. I don't know though. I don't know if this Arduino is running on top of, is really just an FPGA, and I don't know if it has an SPI block in it, which is what I would need to communicate with the SD cards. And I'm toying with the idea of switching to new hardware, maybe a Teensy, but I'd like to get something that I can actually debug, that's not running an Arduino. And I want to get one of those like Teensy 4s if I'm going to do that. So I don't. That's a Freescale NXP part. I might have to use a different IDE. I mean, I would definitely have to use it. It's just probably one I've never used before to program it. So there'd be a bit of a learning curve there. I've used Atmel Studio a bunch. So if we can find an Atmel chip that's pretty good for this sort of thing, that's not too expensive. It needs to be like under $20 as well. Shipping included, if possible. So, yeah, if you have ideas for different hardware that this should run on a different controller board, let me know. Absolutely. I'd prefer something small and under $20, but it still has to be able to run fast enough. So, probably needs to be, I would like it to be over 100 megahertz, preferably around 300. And, yeah, not too expensive. So, okay. Well, see what we can come up with there, picking out a different controller and whatnot. I appreciate you all for sticking around. It's been great, and I hope you have a good rest of your Sunday, and have a great week. So I will see you all later.